Welcome to this video, Slide Roll Ratio Demystified. To make our tests relevant to machine elements like bearings and gears, we have to study the contact between surfaces that both slide and roll. Sliding is when there is relative motion between two surfaces. One surface sees the other surface going faster or slower than it. Rolling happens in contacts where at least one of the surfaces is curved, where the contact moves across the face of the curved surface. We can also look from the point of view of the contact, with the two surfaces moving through it, like this. The bottom surface speed is called u1, and the speed of the top surface is called u2. The sliding speed describes how much faster one surface is going than the other, so it's just the difference between the two speeds. We make a choice about which surface we're looking at and which we're looking from. Here, the sliding speed is defined as u2, the speed of the surface we're looking at, minus u1, the speed of the surface we're looking from. The difference in surface speeds creates a shear force at the interface. This is where friction comes from. If there is a lubricant present, the rolling motion draws it in, or entrains it, into the contact. The sliding motion creates a slanted velocity profile, like this, with the fluid moving faster near the faster surface and slower near the slower one. The average speed of a lubricant is found in the middle of the contact and is equal to the average of the two surface speeds. This average is called entrainment speed, because on average, it is the speed at which fluid is entrained into the contact. Entrainment speed is also sometimes called rolling speed. And so we have this metric, slide to roll ratio, which is just the ratio of sliding speed to entrainment speed. It describes how much sliding there is as a fraction of the entrainment speed. This is it algebraically expanded, and because this can evaluate to quite a small fraction, it is often expressed as a percentage. This value is one of the key parameters describing test conditions in a tribometer. Slide roll ratio can take any real value. When the slide roll ratio is equal to 0, that means the sliding speed is 0. And in this case, if there is any motion, it's rolling motion. This is called pure rolling. As we reduce the speed of one of the surfaces, the slide roll ratio increases. Sliding speed increases, and entrainment speed decreases. Eventually, we reach a point where the slower surface is no longer moving. There is still entrainment, but the contact stays in the same place on the stationary surface. This situation is sometimes called pure sliding, and in this case, the slide roll ratio is equal to 200%. If the contact dissipates heat, or if the surfaces are prone to wear, this is now concentrated in this one place on the stationary surface, which may be more aggressive. Reciprocating and 4-ball tribometers always operate under this condition. The portion of the real line below 200% is called co-rotation. In reality, all components experience some sliding. So in gears, because of their shape, the contacts may see slide roll ratios exceeding 50%, while in rolling bearings, it might only be a fraction of a percent. To achieve even higher sliding speeds, we can spin the slower surface in the opposite direction. This is called contra-rotation and further reduces the entrainment speed. As the entrainment speed diminishes to 0 and the surface speeds become equal and opposite, slide roll ratio tends to infinity. This condition, while easily achieved in a tribometer, is unusual and highly aggressive, so we don't usually recommend it. Slide roll ratio can also take either a positive or a negative value, depending on whether the direction of sliding matches or opposes the entrainment direction. This depends on how we define direction of sliding. The definition we've used here, which applies on all PCS trouble hitters, considers positive sliding to be when surface 2 is faster than surface 1, where surface 1 is the component used for friction measurement. So, the MTM ball and the MPR roller are called surface 1. As a result, on the MTM, a positive slidewall ratio implies that the ball is going slower, and on the MPR, a positive slidewall ratio implies that the roller is slower than the discs. Conversely, when surface 1 is faster than surface 2, the SRR is negative by this definition of sliding speed. This is an important distinction because for fatigue testing, the sign of a slidewall ratio also has an influence on the nature and progression of surface fatigue. Thank you for watching our video on slidewall ratio. We hope you've learned something.